All right, good morning. This is note 7. We're writing polynomials from its roots. So let's go ahead and look at vocabulary. It says leading coefficient. So the leading coefficient, this should be a review. The coefficient is a term with the highest degree given in a polynomial. So it's the term given in a polynomial with the highest degree. Okay, so an example of this is going to be something like 5x to the third plus 3x squared plus 2x plus 4. So the degrees are the exponents. So there's these numbers right here. So degrees are exponents. And you're looking for the highest exponent. So in the case of these problems where we're asking you to do a leading coefficient of 1, we're basically saying that you're going to have 1x to some number. Okay? Now we have the word standard form. The definition basically means that you have a form of equations. So let's look at an example. So you have the leading term, obviously, or the leading coefficient. And we have it for, so far you've learned about the standard form of a line, which is going to be ax plus by equals c. And then you have the standard form of a quadratic, which is something you're going to be working with mostly today. And you have ax squared plus bx plus c equals 0. And all you're basically saying is you're going to have the leading coefficient with the leading term in the front, and then everything else is going to go from high to low. So now we're going to talk about just kind of like a math rule. So this is just like the big idea. So what happens here is you have a corollary of the fundamental theorem of algebra. The big idea that we've been working with is basically saying that any polynomial function can be written in a factored form. So any polynomial function can be written in a factored form. So whenever you're writing in a factored form, typically you're talking about real numbers, so real or complex numbers when you're finding the factor form. So these are talking about the roots are real or complex numbers, which we went over last week. The corollary specifically says that all roots of a polynomial equation can be a combination of any type of number. So what we're saying is all roots of a polynomial equation that's EQ for equation, can be a combination of real or complex numbers. Okay, so for A, write a polynomial function with the least degree with zeros, 0 and -7, because remember we're working for roots, and these are the zeros. Write your answer using the variable x in standard form with a leading coefficient of 1. So the first steps are going to be to set up the roots. And this is what it looks like. X equals 0, x equals -7. Make the linear equation So this one is already done because it already equals 0. So to make the linear equation, you're going to say x equals -7. You're going to add 7 to both sides. X plus 7 equals 0. And then you're going to multiply. Okay, so you're going to multiply. So now we're going to take this one and this one. So x plus 7. When I multiply or distribute, I'm going to get x squared plus 7x. And then I would just want to say that it says you need to write with a leading coefficient of 1. So your leading coefficient in 1, and the least degree you can get out of here is 2. So that is your solution. And then we can go over the hint. The hint is basically to build the linear equation with the opposite sign. I want you to show work, but you can show your work in an easier way. So let's go ahead and use this opposite sign hint right here. So we're going to use the hint. Don't get confused though. Write a polynomial function with least degrees with zeros 2 and -2. So I have 2 and -2. Write your answer in standard form. We went over that in the definitions with a leading coefficient of 1. So it's a 1 right here, but we don't need to show the 1. All right, so it's kind of using the hint, but we're still going through the steps. So x equals 2. X equals -2. Write your answer using the variable in standard form with the leading coefficient of 1. We're going to make the linear equation. So the way that you make the linear equation, if I'm going to bring it to the opposite side, I'm going to use the opposite sign. So I'm going to have x, you need the parentheses. It's +2, so I make that -2. And then I have this one, and that is x, that's a -2. I'm going to make that a +2, and then we're going to multiply. Now I'm going to show you a different way of multiplying. I like to do FOIL, and I'm also going to show you the box. So let's method 1 and method 2. X times x is x squared. X times +2 is +2x. -2 times x is -2x. -2 times 2 is -4. So I have x squared minus 4. That's my solution. Here is the box method. I'm going to make a box. It's going to be a 2 by 2. So it's 2 by 2. And then we're going to write these linear expressions on the outside. So x minus 2, x plus 2. And the operation is multiplication. So x times x is x squared. -2 times x is -2x. X times 2 is 2x. That's a +2x. And then x times plus 2 is 2x. Wait, is that right? No, I did that wrong. So -2 times 2 is actually 4. Yep, that's 4. So then when you add going across x squared, -2 plus +2 is 0. So I don't need to write that down. And then I had a 4, but it was a -4. So -4. C, write a polynomial function with least degree of 0, 6, and 7. Write the answer of the variable x in standard form with a leading coefficient of 1. So we know that x equals 0, x equals 6, x equals 7. This one is good. -6 minus 6, x minus 6 equals 0. -7 minus 7, x minus 7 equals 0. Now we're going to multiply x times x minus 6 times x minus 7. Okay, so let's do that. I'm going to multiply the linear function first, these two linears, and then I'm going to multiply the x at the end. So it's going to go x times x minus 6 times x minus 7. I'm going to do this part first. So that part is going to be first. X times x is x squared. X times negative 7 is negative 7x. And then negative 6 times x is negative 6x. Negative 6 times negative 7 is positive 42. Okay, and all of this still has the x. And then I'm going to collect like terms. I bring down the x. X squared minus 13x plus 42. And I'm going to multiply that out. So the last step is to take this one and multiply to each. So then I get x times x squared is x to the third. X to the negative 13x is negative 13x to the third. X times 42 is plus 42x. And that is your solution. D, polynomial function with least degree zeros. That's what I need to know. Write your answer using variable x. I need to know that. Leading coefficient of 1, also in standard form. Okay, so let's use the hint here. So remember, we're going to do the linear equations based on opposite. So this is a positive 2, so it's going to be x minus 2. This is a negative 8, so it's going to be a positive 8x plus 8. And this is a negative 3, so it's x plus 3. And from there, we're just going to multiply. This is a lot of multiplication, so we're just going to break it up. I'm going to multiply these two first. So, and then bring this in at the end. So, x minus 2 times x plus 8. I'm going to do the FOIL. X times x is x squared. X times 8 is plus 8x. Negative 2 times x is negative 2x. Negative 2 plus 8 is negative 16. I'm going to collect like terms. X squared plus 6x minus 16. And then I'm going to take this and multiply it by that right there. So it's x plus 3. Okay, this is long. X squared times x is x to the third. X squared times 3 is plus 3x squared. 6x times x is plus 6x squared. 6x times 3 is plus 18x. Negative 16 times x is negative 16x. Negative 16 times 3 is going to be negative 48. I'm going to collect like terms. X to the third. 3 plus 6. Okay, so these two go together. That's plus 9x squared. These two go together. 18x minus 16x is plus 2x. And then you just bring down the negative 48. That's your answer. Okay, we're going to do this one the long way. So if we look back at our steps, we had to do solve for x, linear form. So I had to solve for x. I had to get the linear form. Then I had to multiply. Okay, remember this is the work that we want to see. So you have to show work. You have to show work. to get full credit. From here, it's going to be x minus 1, or x equals negative 1, right? Let me highlight that. X equals 1, x equals negative 7, x equals 3. So plus 1, x plus 1, minus 1, x minus 1. Let's put these in parentheses because that's what we're going to multiply. Plus 7, x plus 7, minus 3, x minus 3. So we go from here. X plus 1, x minus 1, x plus 7, x minus 3. All right, so let's go through the work. Let's bring this all back together. I have x plus 1. I have x minus 1. I have x plus 7. And I have x minus 3. So we're going to multiply these two. Then the solution from that will get multiplied to that. Solution from all three of these will get multiplied to that. And then we'll have our answer. This is going to be the longest part of your problem. And it has to be correct. So x times x, let's do x plus 1, x minus 1. X times x is x squared. X times negative 1 is negative 1x. 1 times x is positive 1x. And then 1 times negative 1 is negative 1. Collect like terms, x squared, these two go away, minus 1. That's my new factor. And then we bring this down. X plus 7. X squared plus x is x to the third. X squared times 7 is plus 7x squared. Negative 1 times x is negative 1x. Negative 1 times 7 is negative 7. Then there's nothing to collect. There's no collect like terms, so it all just goes together. And we bring down this last term. So you're going to say x to the third times x is x to the fourth. X to the third times negative 3 is negative 3x to the third. We do it like this because we're going to make our groups. It's going to be easier for us to make our groups and collect like terms. 7x squared times x is positive 7x to the third. 7x squared times negative 3 is negative 21x squared. Remember, that's a positive x. Negative 1 times positive x is going to be negative 1x squared. Negative 1x times negative 3 is positive 3x. Negative 7 times x is negative 7x. Negative 3 times negative 7, positive 21. So let's go ahead and group them. Anything to the third power with the same base goes together. Anything to the second power with the same base goes together. Anything to the first power with the same base goes together. And I want you to remember that it carries a sign that's in front of it. So the signs are super important when you're adding, subtracting, and collecting polynomials. Or collecting like terms for polynomials. So our solution is going to be x to the fourth, negative 3x plus 7x. There's more positive, so it's actually 7 minus 3. Positive 4x to the third. Negative 21x squared minus 1x squared. They're both negative, so you're going to add. but the sign is negative. So 21 plus 1, 22x squared. Positive 3x minus 7x. The 7 is larger, so I know my sign will be negative. 7, so you're going to look at the number 7 minus 3. Even though we have a negative sign as our solution, in your mind, you're just going to think, because this is smaller, I can subtract it from the larger number. So 7 minus 3 is going to be 4x, and then you just bring down the constant because there's nothing to combine it with. And then you had the 1. So if we go back to the original problem, it says that your leading coefficient has to have a 1 in front of it. So I get 1x to the 4th plus 4x to the 3rd minus 22x squared minus 4x plus 21. This is your solution. And then I want to talk to you about the homework or the classwork. I have one in front of me. Okay, so let's look at the worksheet. And here's just like kind of like a hint. When you're working through these, I think I gave you 10 of them. You can tell me by looking at the zeros what the leading term value is. So if we're talking about the leading term, we know that we want the leading coefficient to be 1. So we know that's going to be a 1. But what is the power of the function? Because I have 2 zeros, I could say I know it's going to be x squared. So if you're going through your solutions and like say this one doesn't start with the 1x squared, then it's wrong. If we look at something like number 10, number 10 has 1, 2, 3, 4. It has 4 roots. So now I can say that I have x equals -2, x equals -1, x equals 0, x equals 3. So I know that my leading term needs to have a 1 coefficient, but it's going to be x to what power? I have 1, 2, 3, 4 roots. So when it says the least degree, it's going to be 1x to the 4th. And that's the least degree that I can do. So if, say we had a test and I said, what is the least degree? And then let's suppose I gave you this. In this case, it would be x to the 4th. Okay? See you in class.